All right, everybody, welcome back to class. I hope you had a nice 3-day weekend and are ready to jump back in because we actually have the semester's really getting rolling now. We have Lab 2 due tomorrow, anytime on Earth, and we have Project 1 due not this week but the next week. So the second half of class today, we'll be going through both of those. So hopefully, if you haven't started them, you'll be ready to start. If you have already started, maybe you've gotten to some things that were confusing or we haven't covered yet. We'll cover some final things for both of those actually today. Hopefully that will get all cleared up. If not, ask questions during class, come up to me after class, ask in lab, ask on Discord. So, as a reminder, here we are, Wednesday, the 7th, just had Labor Day. We can see we've got Lab 2. We'll finally move on to some new examples of classes. I know we've really been beating this counter class to death, and we will actually look at it again today to finish off modifiers, but in lab tomorrow, you're going to see, you'll make your own animal class, so that's something new. And then on Friday, we'll see an even more complex class, which will be this credit card class. So hopefully that will continue getting you more comfortable with object-oriented programming. I know, especially if you didn't come from 127, it can be hard, and I do encourage you, if you're really lost on object-oriented programming, like what are constructors, what are methods, what are fields, try to seek out some additional sources online, or you can message me or talk to your TA, but we're going to be continuing defining our own classes throughout the class, so we definitely want to make sure that you get that down. So for today, we're going to jump back to Friday's lecture so we finished up with the keyword this, and I hope that wasn't too confusing. Basically, you're just going to need the keyword this if you want to refer to the object itself. So it's the same as self in Python. One thing that we are going to address today that I hope will make these Java programs seem a little bit less mysterious are modifiers. So that's like the public, like if you think of our main, we have a bunch of modifiers in front of that main method, right? We have public static void, well, public and static, and then we have the return type void. So we can clear some of that up today and set you up for the lab and the project. So to start off, I'm going to grab, I did update the files here to what we finished with on Friday. So I guess I'll just go ahead and copy that over just in case. So I'm just going to copy the code here. For me, I will put it in my day 5 package, so I would be okay there. So I got my day 5 package. I'm going to open up. I have a counter file already. I'm just going to paste this in. I think it's the same, but I'll just paste it in just in case. And I'm also going to open up my counter demo. And I'm going to paste in from that lecture 5 page. I'm going to copy over this counter demo class into my counter demo file. And so this should be, oh great, I have an error. Let's see. Where? Oh, thank you. Good catch. Also, how's this sides looking for people in the back? Anyone? Okay, cool. Great. So I don't have any errors. That's great. I run this, and okay, let's just reorient ourselves. We have some counter objects. They just count things up. Actually, I met someone today who works at like a lab, and he has to sit there like all day and just click a counter to count how many like bacteria individuals there are. And I was like, oh my gosh, my 132 students implemented a counter, or we're implementing a counter just like that. So anyway, if it was a digital counter, this might be what was in there. So we're just counting things up, and we implemented add on Friday, I believe. So we can take in another counter and add whatever its value is. So what do we want to do today? We want to look at these modifiers. So, okay, I think we've actually touched on this already in class, but a lot of times maybe our sort of default is to make, when we declare our methods, and okay, let's go back to our counter class. We can see that our fields and our methods, including our constructors, they all have a visibility modifier. So, and that visibility, for now, it's fine if we either think of it as private or public. Does anybody want to tell me what it means? What's the difference between public and private? Any takers? Yeah.
Private can only be accessed in its own class. Public can be accessed within its own private class.
Yeah, precisely. So here I am inside the counter class, and so the field count, it can be accessed just fine within my methods that I'm defining in the class, right? Like, you know, I'm incrementing count right here, I'm returning count right here. Clearly private isn't restricting me from being able to use count or even see count within the class. But once I come over to my counter demo class, I have a counter D, and like let's say I wanted to just print out that count field directly, or even look at it. If I did something like I wanted to print it, so I'm gonna system.out.println. I want to print it, so what if I just do d.count? Well, Java is not going to let me do that because it's private, and I can't even run anything, so clearly that's not working. But if I change this to public, now actually I don't have any errors, and I can run that. So when a field or a method is private, it can only be seen and used within the class. So let's change this back to private. Yeah, okay. So next, we're going to talk about the static modifier. So as I mentioned, we have seen the static modifier before in our main class, but how we can use static is we use the static modifier on fields and on methods when we want these to be associated to the class as a whole instead of to instances of class. And this might feel like a distinction that's a little fuzzy, but I think once you've been programming for a while, it will be a distinction that makes a lot of sense. If you need to just trust me on it, for now that's fine. But sometimes there are things that just make sense to be associated to the whole class rather than instances. For example, let's say I had another field and it was a description of what the counter object is. Like in general, what are counter objects? So I could declare a field. I want it to be public because I want someone outside. Basically, I want to be able to come out here and print, like even let's say before I even did any of this stuff, I wanted to get some info about counters in general. And so I'd like to do something like counter dot, what did I call it? Called it about. And so I'd like to print this out. So we haven't implemented this yet, but if I just say public static, and now this is going to be a string, it's just going to be a little about statement, and it's going to say a counter to count things. And this is just like some info about what counters are. And I need a semicolon. And now I can run this, and I have successfully printed this. So you notice that I didn't instantiate any counters before this. Java will let me call a static field or static method on an instance. For example, it's going to let me do something like, I have an instance d dot about, but it's going to give me a warning, which you probably can't see, but if you did it for yourself, and the warning says the static field counter dot about should be accessed in a static way, and when it gives me that warning, it's saying you made this static for a reason, and that is that it's for the whole class, not for instances. Are there any questions about that? I know it's kind of a subtle, yeah. Yeah. And so can anyone tell me if I take away this static, like, let's say I delete this, what's going to happen in this case? What will be different about how I would have to get my about? Yeah. What was that? That's a good thought. But I already had to, so I already had to print line to get it. Any other thoughts? Yeah. Yeah, I can only access it once I have through an instance, exactly. So I have to instantiate a counter object, for which I do, for example, here. And then I would access it through using the dot notation on the instance. Yeah, this is a subtle difference. I hope that with some practice, this will become more clear. And you do need to do this on your project. So we'll go over that at the end of class today. Let's see. I'll put this back. And I'll delete this. Okay, so we've got public versus private. We've got static, which is just optional. We leave it off when we want instance variables and methods that apply to instances. There's also the abstract modifier. Your book mentions it, but we're going to get into this later when we get into some more higher level Java topics. So for now, don't worry about abstract. You don't have to do it in labs or programs for now. But one more useful modifier is final. Anybody? I guess it says it here, but any ideas on why we would want a modifier like final? Yeah. Yeah, exactly. There are some things that we don't want to be able to change. But we still want to be public. So if you've taken a look at the project, you need to save a value of pi as a field in your program, in your class. And you want that to be public because, or I guess we can make it, it's fine for it to be public, but we don't want someone using the calculator class to be able to change, like, what is pi? Yeah.
So it would be like if you had an online test and someone submitted their answer, they could still look at that answer, but they couldn't, and maybe even write comments on it, but they couldn't change what their submitted answer would be.
I think that's a good example. Yeah. I guess I often think of them as things that just are defined from the very beginning, and I guess I would have to actually check whether you can. My guess is that whether you can have a final variable that's actually set by the user. So in the project, I think we could actually pull it up right now. Project 1 starter, calculator. Okay. Oh, I guess we haven't implemented it yet to start. Okay, so in the project, you're going to make a field that's called roughly pi, and it'll just be set from the beginning. You know, you don't set it midway through the execution of the program. It's just set as soon as a calculator is instantiated. So I'd actually need to double check whether you can make something that you set midway through final. But basically, this is when we want something to be constant throughout the entire program. And yeah, for example, let's see. Yeah, I guess like we could actually set our about string to be final. There's no reason why the user should be able to change this value. So we could set that to be final, and our program still runs. We're just accessing the about field here now. So okay, so let's take a look at. Oh no, there's one last thing that we need to cover because it's in the lab. So if we look at today's lecture, so in Python, does anybody? Oh, you have a question.
With that final keyword, can you declare that anywhere? Like just say like any variable anywhere.
Is final.
Is final at whatever point it needs to select one actual.
Well, yeah, that's a good question. I think you can. Let's just double check. Does counter have a logical thing that we can make final? I mean, I guess instance variables have to be, like, our instance variables have to be declared outside of a method. So it's like they already exist. I can't just inside a method, like, unlike Python, where you can create instance variables anytime. You just say self dot. Like in Python, let's say for some reason, whenever I increment, I have like some, let's say I wanted to count how many times I've called increment. I want to let's say I want to count how many times I've called increment. Any thoughts about how we would do this? Like what would I need to do if I just wanted at any point I have a counter and I want to know how many times I've called increment? What would I need to do? So I want to be able to say, let's say I want to be able to say d dot get increment count, and this should tell me how many times increment has been called, specifically on D, on the counter D. So we can look back and see, okay, so for D, it's been called one time, right? Does that make sense to everybody? Looks good to me. So in this case, like, this should return 1. In this case, it's 1. So how, if I wanted to do that, what would a first step be? Any ideas? Yeah.
Creating another, well, I guess in the fields, creating another variable to keep track of how many times.
Yeah, exactly. I'm going to need a field, something like private int inc count, right? Or inker count, maybe. Exactly. And then, yeah, what else? Okay, so now that I've declared this field, or now that I've defined this field, what would I need to do to make this method work for me? Any thoughts? Yeah.
Every time you call that increment, you need to add 1.
Yeah, exactly. So now my counter just has layers of counting, but I'm going to have to say inker count plus plus. And then I have, so I made it private, so I'm going to need and I've specified that I want a get inker count method. So let's say I just wanted to put that here. Anyone want to tell me what that would look like? Yeah.
And basically the top one just changes.
Yeah, exactly. Public. And then I need to return an int, and I got get inker count. And oops. And I'm going to return inker count. So the point of this whole exercise, in addition to practicing with classes in general, is that in order to keep track of this, I have to declare this, I have to define this field in my class. Unlike Python, where maybe I make this decision as I'm writing my class, in Python I could have just, added a like self.inker count, I don't have to necessarily, I can create my fields in the constructor in Python, but I don't have to in Java. So I think that would prevent just like making something final midway through, because when you declare it up here, that's where you would make something final, to answer the question. Okay. Make sure we didn't break anything. Great. Okay, so last thing to cover before we talk about the lab is toString. So does anybody remember operator overloading in Python? Is that, yeah, what does a saw nod? What does that mean to you?
All the double underscore methods.
Yeah, exactly. There were all these underscore methods, which I always really liked that about Python, that you can do things like, here we made this add, but in Python, I would have thought it would have been a lot nicer to do something like, I can't remember if it was maybe like this. We would do like def add, I really can't remember my Python syntax, but exactly these double underscore methods, and that meant that when we actually called, rather than having to call add, we could use the plus sign. And I think that's a nice thing about Python. Java doesn't have that, but it does have, it does have something similar for string representations of our objects. So if you remember, let's say I want to print out my counter. If you remember, if I just print out D, I just get the memory location of this object, and that's not very satisfying. If I want instead, because that's what the default string representation of this object is. If instead I want a more useful string representation of my object, I can override the toString method, the built-in toString method. So to do this, let's double check what I have written here. Okay. I guess I point to a reference, but we will just do it ourselves here. So this will be public. We want to call it. It's going to return a string, and every time we do this, we have to call the method toString to actually overwrite that built-in method. It doesn't need to take in anything, but whatever we return here, return our chosen representation, string representation for this object. So that's what the toString method needs to do. And so what would be a good idea, like what should we print out if we want a string representation of an instance of our counter object? What's an idea for that? Yeah. Yeah. So yeah, maybe so we definitely want to print the current count. I guess we also, maybe let's print the current count. We added this anchor count, but it was kind of just for demonstration purposes, so let's not worry about that. And maybe I might do something like, I want to print something like counter with count of, and then in this case it would be whatever the count is. So I believe our D, so let's say maybe I want my, when I call D, when I call print line on D, maybe I want it to print something like counter with count of 8, because that's what D's count is currently, right? In our program. We have a comment here saying that. So if I want that to happen, can anyone tell me what I should return? Yeah, so I definitely want, I was thinking, so if I just wanted to return the current count, I could do something like, what would I have to, if I want, so one option is probably count, and I think, will it be cast to a string? I think I have to. Well, what I was thinking was that we were going to do the string counter with count of, and then something like that. And now I have a string that says counter with count of, and then I will have whatever my current count is. So we can run this, and it works. Let's say I wanted to call the method, the getCount method. Anybody know like what I would have to say if I wanted to call the getCount method? Yeah. Yeah, exactly. So that's where our this is coming in, because if I don't have this, how do I actually specify? I need an instance to call getCount, right? So that's where my this comes in. This would work as well. And we can even run it again and see that it worked. Great. So overriding the toString method is something you're going to need to do on lab 2. So let's jump over there and take a look at that. How many people have started on lab 2? A lot of people. That's awesome. Oops. So one thing I want to point out is that for lab 2, you need to turn in 2 Java files if you don't demonstrate it to your TA. So you've got both your animal class and your animal demo class. So your animal class, don't love this header that I wrote here, but that's okay. So the animal class needs to have 3 private fields and 6 public methods with these variable names and method names. And yeah, it's important that you do override the toString method. So, you know, you could get, do I have an example? You can get this sample output without necessarily following all the instructions here, but you do need to follow the instructions to get full points. So you need to override the toString method. You're going to need to have 2 constructors. And then in the sample run, there are specific things that you're supposed to do. So you should first initialize 2 animal objects. One constructed with a specific name, age, and species. The other one should be with the default values. So that means that you're calling the constructor with no inputs, right? Your animal demo.java should then print these 2 using just by calling system.out.println. And then you should prompt the user for another animal. So you're going to be needing to use the scanner. Get those 3 attributes from the user and then print it out. So I guess that's as big as it goes. So this would be a sample output. Are there any questions so far? Yeah.
So the second animal, you said you needed the default values, so you should put that for the name as well.
Yes. I think you're right. So oh. Okay, yeah. Thank you. Okay. Oh, yeah. Very true. So there's no both really good points. Thank you. So what inside the program, what you should be doing. So this one you're creating with the constructor that takes in the 3 inputs. This one, in your code, you're going to have to first create the object with the default constructor and then call the setter methods. Does that make sense? So definitely read the instructions closely on this one. And then, yeah, prompting. Yeah. For the grading, let's see, display the 2. Yeah, you got points for how you actually do things. And then you're going to need to prompt and display. And then, so this go beyond section, I'm going to try to start adding to the labs. These will be ungraded. Don't turn this in, but feel free to show it to your TA if you'd like. This is just a possible thing for you to try to push your knowledge a bit further, get some more practice. So for this one, if you'd like, you can also implement a zoo class where the zoo class has a field that is an array of animal objects. So here you would be, yeah. No extra points, sadly. Just if you want to procrastinate on your other homework, I highly suggest doing this, yes.
So I have a question about that. Is that a 2D array with like a bunch of like lists of like, so it'll be like the age, the name, and everything?
So
Or would it be the actual object?
it'll be an actual array of the objects. Yeah. Yeah.
When you're turning your Java files in, I just zip my whole project. Does that work too?
Yeah, that works fine. Yeah, as long as it's obvious for your TA to get to the Java files, you know, you wouldn't want to turn in like a PDF of your Java files because then they have to figure out how to like copy and paste that in. But yeah, zipped folder of them is totally fine. Yeah. So this is lab 2. Sounds like a lot of people have started already, and that's awesome. Okay. And also, let's take a look at project 1. Yeah, I think this is kind of a fun one. Lots of little things to change and start to deepen your understanding. Oh, I never did the partner option. So good thing I'm talking about this now. Okay. So, all right. So for project 1, you actually have some starting code. What we're going to do is implement a calculator. So just like, you know, a physical calculator that you might have or a calculator that you have on your computer. Let's see, I probably have one. Haven't opened it in a long time. You know, we are going to implement a calculator. So you're going to be able to do operations like, you know, plus. And plus is already implemented for you, but you're going to want to be able to multiply, divide, etc. Plus there's some weird little ones in there. But to start off, you will take these calculator.java and calculator.demo.java files, put them in one package, and then to work on the project, you are going to edit this calculator.java file. You don't need to make any changes to calculator.demo.java, but when you turn it in, I will have you turn in both, just in case I don't make changes to calculator demo, but I don't want your TA to be, they can maybe potentially track down issues in grading if you turn in both. So do turn in both, but I suggest only making changes to calculator.java. So I already have these pulled up. So I'm just going to open them up. So just like we've been doing, we have one file, which is my calculator.java file, where we are defining a calculator class. A lot of stuff is done for you, but not everything. And then we have calculator demo, where we have a main method and we actually use our calculator. And so this is going to work if we run it as is. So we are creating a calculator using a constructor. And to start off, you can see that we call the getUserNum method to get a number from the user. So for example, 6. And then we have a bunch of operations that you are going to need to implement. Let's go down here to the list. Let's see. So yeah, I would focus your attention on the grading, both the grading and the sample code. So first, you will be graded on your readable code, and we'll talk about java.comments next week. So you don't need to worry about those. You can add them in at the end, or you can look ahead in the book or look ahead online about java.comments. But you're going to have these 5 fields, and we have a bunch of methods that define, these will define the operators that your calculator needs to correctly execute. So for example, if I do 6 plus 4 and equals, you can see that this is already working. 6 plus 4 does equal 10. But you notice that when I pressed equals, I did print out the answer, but you can see there's a to-do here. This needs to be formatted. And if we go over to the calculator.java, you can also see there's a to-do here. And there might not be a to-do in every place that you need to change the code, but do pay attention to the to-dos. So we saw that plus was implemented, but okay, let's see. So we have 10. Let's say we multiply 10. We want to multiply, so we do star. Let's say I want to multiply this by 10 again, and now I press enter equals to see what it is. You see that we clearly didn't multiply by 10. And that is because if we go to our calculator class and we see what are we supposed to do with the star, well, it's not implemented yet. You need to implement it. So there are a bunch of these here that you need to implement. There might be other changes that you need to make in the code to make those work. And also, you should be able to enter, if I were to type plus pi, oh, okay, so I guess the pi is implemented a little bit, but you're going to have to make some changes to that as well. Let's see if there's anything else I wanted to say. Yes, there is. One important thing to note is that you don't need to implement like log or exponentiation or random yourself. You should use the built-in math class, and you can find the documentation by clicking on this link. If you are finding that you're like, okay, I know where my method needs to go, I don't even know how to implement, I don't know how to implement, let's see. One that might be hard is perturb. I just don't even know how to implement perturb. Ask about it rather than spending a lot of time on that. Because the point here is to work with classes, not to get stuck on implementation. Yeah.
Will you always provide source code, or will we build projects from scratch?
I haven't decided about all the projects, but my guess is that some of them, I haven't decided yet. But I think it's definitely a good place to start on this one, is to start with source code. Are there any other things I wanted to note? I don't think so. Are there any other questions on project 1? Cool. The one thing I'll say is that I didn't cover controlling the flow today, but a lot of this is basically the same as Python, and there are examples of this we covered for loops, while loops from Python. Do while is very similar to while. There's an example in the example source code. You can also find it in the book, find it online. Also, if statements, very similar to Python. Switch is a little bit weird, and I think I'll post a example to point you to, but you can also take a look at there's a switch statement in the existing code, and I'll point you to an example online, but you could also look this one up as well. So we're not specifically going to cover this, but it's very similar to what you've done with other programming. And yeah, if there are any other questions, I can take them, but otherwise we are good for today, and have a good rest of your afternoon.
Yeah, so I just looked that up. Yeah, that's awesome. Yeah, that'd be good. Three schools. Things like this library. Yeah, I think that's but yeah, that was literally, it was the sentence part that wasn't fully.
Thank you.
Thank you.
Yeah, thanks. Hey.
So when we're doing, so when you're setting up the animals, do you just have them set up with the default values?
So, you should, so rather than passing in unnamed -1 and unknown,
Just have it in the.
you should have a constructor that
Inside,
takes
okay.
no arguments.
That takes no arguments.
Yeah, so you're allowed to, you can define as many constructors as you want, as long as they have taken different, as long as they can be differentiated by the arguments that they take in. So you can define, so you're going to want to define another constructor like we did for, on the counter. You saw on the counter, we have one counter where it's initialized, it doesn't take in anything, and it doesn't do anything actually. There's no code in there, and so the count variable is just initialized to 0, because that's the default range. So yeah, you're going to want a constructor that takes in no arguments.
Okay.
Yeah. And then
So
figure out what it should do from there.
Okay. And then.
Oh, I should turn off my recording.